Okay, this is the Math 1111 Zoom meeting for Thursday, October 22nd. So we're going to work some problems from 3.5 and 3.6. 3.5 starts right here. On this page, they basically all factor. Notice they want you to factor the polynomial, find all its zeros, state the multiplicity of each zero. That's the power of it. They all factor. On the next page, they don't. So on these, we can factor. We can pick one like 29. And in 3.5, they generalized it. So some of these zeros are whole numbers or fractions, like last section, and are real, in other words, and some are imaginary, have imaginary zeros. Why don't we pick one like 29? That's the more general case, is you're doing imaginary zeros. It's off page 329, 3.5, and it's P of x, x cubed, add x squared, add 9x, add 9. We could do I could do these by making that list of all possible factors and then finding, you want to see it done that way, or do you want to see it factored? They have cooked this to factor.
Probably it factored.
Okay. Well, with 4 pieces,
What did you say? Sorry.
Well, remember, there's a way to find the zero. I don't know if you can hear me now because it's gone unstable. Okay, can you hear me now? Now
yeah, your voice is like messing up a little bit, but it's not terrible.
Okay, it gave me an unstable message. Remember, there's a way to form a list of all possible factors. We called it P over Q. And you take factors of 9 over factors of 1 and punch them in your calculator, see which ones give you 0.
Yeah.
Okay, well, we could play it that way. But you can also play it. Go ahead.
I'll say the other way just because I think I know how to do the first way like pretty well, you know?
Okay. Well, if you can factor this one's been cooked to factor directly by grouping, meaning take out the x squared, you're left with x plus 1. You can put an x plus 1 over here, and then you got to figure out, gee, what do I stick here to multiply back? Well, you got a 9x, a plain x, got to be a plus 9.
Yeah.
Yeah, and then you can see it's a 9x plus 9. Remember, every line's got to multiply back to the line above or you're screwing up.
Awesome.
And, yeah, now you've got a common factor of x plus 1, which you pull out. Oops. Make a big parentheses the other way. And you're left with the x squared plus 9.
Perfect.
Not starting off really good. Scribbling around here. Okay, so you pull out the x plus 1, then a parentheses, and you're left with x squared plus 9.
Yeah.
Okay, if you again set this to 0 to get your zeros, you can see you had a 0 here of -1.
Yeah, -1, and then would it be, wait.
Okay, now see the other one, that's going to be your imaginary 0. That's what they've done to you.
Yeah.
You're going to have x squared plus 9 equals 0. X squared will equal -9. When you do a square root, you'll get a plus and minus. Root 9 is 3. And that negative inside gives you an I.
Awesome.
So you will not find that on the list of all possible zeros.
Yeah.
But there are your 3 zeros.
Awesome.
Okay. So when it says factor completely, we've actually already done it on that line.
Sounds good.
Yeah,
can you find the imaginary ones when you factor it the other way, or is it only that way?
No, only this way.
Okay, cool. That's what I figured, because with the other way, you kind of have to guess.
Yeah, you'd have, that only gives you real zeros. Factors of 9 divided by factors of 1. So that'd be like plus minus 1, plus minus 3, and plus minus 5.
Perfect.
Plus minus 9, my fault. Plus minus 9. And only the -1 when we checked them out on the calculator, only the -1 would give you 0.
Yeah.
Okay, so these two, this plus minus 3i are not going to show up.
Awesome.
All right, but yeah, since it was cooked to factor completely, we can factor completely first, solve each factor, and then find your zeros. And that's really all it asked for. It did want multiplicity of each zero. Multiplicity here is going to be 1. Well, okay, if you want to be really technical, the factor completely really should go x plus 1, x minus 3i, and x plus 3i.
Awesome.
And then you have 1, 1, 1, so x equals -1 has multiplicity of 1. X equals 3i has a multiplicity of 1, and x equals -3i, multiplicity of 1.
Perfect.
Okay, so all of these have been cooked to factor that way. So do you want the more general case? That's on the next page. They turn into project. Actually, the next section is going to make you go backwards. They're going to give you the zeros and make you find the polynomial.
Oh, that might be useful to see.
Okay. So that is page 330. Yeah, these are kind of the backwards. So they're telling you the degree. You're starting off with a quadratic x squared. Degree 3 would be an x cubed on the lead p. Degree 4 would be x fourth, and 46 an even one. Well, I guess we won't mess with that. All right, and then down here are the more general ones. They won't factor directly. You'll have to play your factors of the end over factors of the first to get a list. Kind of the whole schmo.
Yeah, totally.
Figure out if any of them actually are zeros, and then use that to figure out the rest of them. All right, but do you want to see a degree 3 backwards or degree 4 backwards?
Degree 3 sounds good.
Okay, so that would say be 39.
Yeah, totally.
Okay. Well, let's try 41. I'll make a point about this. All right, find a polynomial. P degree 3, zeros, 2, and I. Okay, so here's the point. Notice degree 3 is supposed to be 3 zeros. Well, they've only given us 2. You're given 2. Oh no, where's my third zero?
No.
Did we get across the conjugate zeros theorem?
I'm not sure.
Okay. The point being, they only give you one. If there's a complex number, an imaginary number that's a 0, they only have to give you one of them. This complex conjugate is the switch of the sign. In other words, for this one,
Okay.
minus I, also a 0. And they assume you,
Yeah, totally.
yeah, they assume you know that, and therefore only feel obligated to give you 2 of them.
Okay.
So you now create your factors. Your factors, if 2 is a 0, the factor is x minus 2. If I is a 0, you have x minus I. And if negative I is a 0, you have x, you could say plus I minus a negative I, and that would be x plus I.
Awesome.
So, yeah, 2 minus 2 is 0, I minus I is 0, and a negative I add I would be 0. And now
Perfect.
it's simply a matter of multiplying them all together. So x minus 2, x minus I, x add I. Now, this is what I try to really emphasize. It's really not that hard foiling all this out, but people get confused, don't combine the pieces right or whatever, and wind up with an I in the final answer. If you do that, you're screwing up.
Okay, so you shouldn't have an imaginary 0 in the last answer?
In the final answer, it should read like an x cubed, an x squared, an x, and a number.
Okay.
With no i's. If you wind up with an I in that, you've screwed up.
How do you get rid of the I?
It will get rid of it by properly doing this.
Okay.
Final answer. All right, now the order you do this doesn't matter. I usually do like the first two and hang this on. There's no scheme to go through all three. So
yeah,
the first two, x squared. And you x times negative I x. Doesn't really matter the order you write the letters. You'll have a minus 2x, and a plus 2I. And you have an x plus I. That go too fast?
Oh, no, I think I'm getting it.
None of these pieces are alike, all got different letters in them. So we're just going to go on, and I just, again, multiply each of these by both of those and write it down.
Yeah.
So x squared times x cubed. X squared times I, I'll write it ix squared. Or you can write it x squared I, either one. There's round one.
Perfect.
Okay, so minus ix times x, that's a minus ix squared. Minus ix times I would be a minus I squared x. Round two. It's looking like total gibberish, but we'll unravel it. We're halfway there. That's round two. Any questions about that?
No, it makes sense so far. I'm assuming the i's are just going to cancel each other out.
Eventually, and remember, an I squared is always -1.
Yeah. Oh, yeah, that makes sense. Sorry.
No problem. So round three is -2x times x, -2x squared. We'll call it -2xi, or I'll write it ix, either one. -2 times ix. It's round three. I'm trying to work real slow because I'm going to be very embarrassed if I screw it up and find an I in my answer.
That's fair.
Plus 2ix, round four, and plus 2I squared.
Awesome.
All right. Well, you got your x cubed. There's your degree 3. If you want to cross them out so you don't use any more. All right. There's an ix squared. We ought to find a negative ix squared somewhere. Right here. No, that's a negative I squared. I'm sorry. Oh, it's right next to it. Ix squared minus ix squared.
Yeah, so those can cancel out.
Cancel out. All right, we'll stick a -1 there. So -1 on x, that's a positive x. All right, we got a minus 2x squared. So if you want, we've handled that. All right, minus 2ix plus 2ix. That's nice, they're gone.
Perfect.
And I squared on the end's a -1, so 2 times -1 is a -2.
2. Awesome.
Yeah, no i's in the answer. It's a little scrambled, but it's perfectly legal. If I'd obviously mark you full credit if you wrote this down, but just to put it in order, you'd have x cubed minus 2x squared, add x, and minus 2.
Perfect.
If you really wanted to be anal, you could check each of these and prove that you really get out 0. Are you dying to see that in 2-3 more pages of gibberish, or do we all believe?
I believe how it is right now. It makes sense.
Okay. All right. Let's see. So before we get on to 3-6, did you want to see one of the Real man problems. These will turn you into a real man.
I'll
Old schmuck.
say 1, you know, might as well.
Okay, which one? You starting off with degree 3s?
Um,
And you get
I'll make it easy on you and say like maybe 52.
Want an even one?
Yeah, sure.
Okay, 52. $330 P of x, x cubed, add x as, I'm sorry, subtract x, subtract 6. Okay, this is still 3/5. Okay, yeah, there's no cubic formula. You get above 2 there. If that's a 2, it's a nice, easy quadratic formula. In fact, it even factors. But with an x cubed, all those rules out the window. So we are going to be stuck with our list of all possible zeros to try to get off the starting block here. You want to find zeros and factor. Possible zeros. All right, do I need to remind you what that is, or can we just start?
That would be -6/1, right?
Yeah, factors is, so factors is plus minus 1, plus minus 2, plus minus 3.
Oh yeah, they're over each other.
Yeah, plus minus over plus minus 1. All right, so yeah, when that happens, that's not going to change any of these.
Yeah.
All right, so we're going to run, instead of individually punching them in, there's 8 of them. We're going to run to the calculator. If I can find mine, yeah, right here. And did we get across how this works?
I believe so, yes.
Okay, so punch in the formula, x to the third minus x minus 6. And don't have to punch in these possible zeros. The calculator automatically handles integers. Just make sure I'm in automatic. So table set, I'm in auto mode. So I'm going to go to table. Ah, sure enough, 2 is 1. 2 is a 0. So x equals 2, zeros. All right, and I can go, doesn't look like I'm going to get any more. I always try to check the positive, but you can see it just getting bigger and bigger.
Yeah.
So go the other way, 2 is a 0, and it's just getting more negative.
Perfect.
So the only one off that's a lot quicker than individually punching them all in, I can tell you that.
Yeah.
Which means that my x cubed minus x minus 6, see the factor for that is going to be x minus 2. X minus 2. Which means I'll have a factor of x minus 2 times junk. We gotten this across?
Yeah, totally.
Yeah, 2 gives you 0 out of this, and 2 minus 2 gives you 0 on this side.
Perfect.
Okay, have we gotten across how to find the junk?
I believe so.
It has more technical name. It's called the quotient. You're going to have to, it's like solving an equation. You got to divide both sides by the x minus 2.
Awesome.
And when you do, your quotient will come out this, and that'll be your next factor.
Yeah.
And it will divide evenly. Once again, there's a few spots here you can tell what's going to predict what's going to happen if you do it correctly. It will divide evenly.
Okay.
If it doesn't, you're screwing up.
Fair enough. Just try again, I guess, if it doesn't work.
Now, are you into, this could be done by synthetic since that's a first?
Synthetic's pretty easy if that's what you mean. That's usually the one that I go for.
Okay, so if you know synthetic, help yourself. I don't. So I will do it long. X cubed.
Fair enough.
I always put in a 0 x squared missing piece minus x minus 6. All right, so x times what's x cubed? That's in x squared. Giving me x cubed minus 2x squared. Subtract, put this in parentheses. 0 minus negative, that'll be a positive 2x squared. Minus x minus 6. X into 2x squared will be a 2x. 2x squared minus 4x. Subtract. Negative minus negative, that'll be -1. Add 4, that'll be a 3x minus 6. Game's still not over. I can still, if the powers are the same, I can still play the game. So I get a +3. 3x minus 6. Ah, sure enough. Can you tell? It went evenly. And this is my junk.
Awesome.
Which means my x cubed minus x minus 6, my original polynomial, has factors of x minus 2 and x squared plus 2x and plus 3. Again, if you wanted to check at each spot, you could FOIL this back and you should get this. You want to see that done, or do we believe?
I believe.
Believe. Okay, good. So you have, again, a 0. We already know we have a 0 at x equals 2. Now, if you really wanted to be anal, you could rinse and repeat this whole process, getting your list of all possible zeros for this and punch them in the calculator, etc. But why should we do that when we know we have a what? A quadratic formula.
Yeah.
So we'll just use that. So for x squared plus 2x plus 3 equals 0. You could factor it if you want. I don't think the signs are right to factor it. I think the sign's off. You'd have x plus 3, x plus 1, and you'd get a 4 instead of a 2. So we're stuck with the formula, -2. 2 squared is 4 minus 4 times 1 times 3. Yeah, you can tell you're going to get a negative under that root. Divided by 2, 2a is 2. So that's going to be -2, add and subtract the square root of -12. I'm sorry, it's 4 minus -8, my fault.
That's good.
4 minus 12 is -8 over 2. I don't really make people, boil it down, but the answer in the book, you're going to get an I for the square root of negative, and root 8 is going to be what, root 4, root 2?
Yeah.
Over 2. All right, and then root 4 is 2, so you're going to get -2, add and subtract I 2 root 2. And then
Perfect.
play it, factor out that common 2 and cancel, or you can divide out both like you're distributing. So you're going to get -1, add and subtract I square root of 2.
Yeah.
Now it just said find all zeros. And so x equals 2 was a 0. So there you are. It only took 3 pages. I write big.
Yeah, totally. It made sense though.
Okay. All right, well, that's about everything in 3.5. We're 30 minutes. Did you want to see something out of 3.6?
Honestly, 3.6 made more sense than 3.5.
Okay.
Perfect. And then, like I said, if anything like really confuses me, I do have tutoring in like 2.5 hours now. It was just trying to I wanted to have like a basis to go into tutoring with,
All right, well, sure thing. So if we've shown you enough, don't feel obligated to hang around. I think for completeness, I'll work 1.3.6 problem.
Perfect.
For anybody who wants to watch it. So yeah, if you don't feel obligated to hang around.
Awesome. Yeah, I'll probably head out just because I get 3.6 pretty well. But thanks for having me, man.
Oh, absolutely. Yes. Appreciate you coming out.
Yeah, awesome.
Good rest of the day.
Of course. You too. Bye.
Bye. Okay, so we're going to work a 3.6 problem. Just for anybody watching this, we're going to pick one out of the entire thing. Earlier, they'd zero in, like here they just zero one x and y intercepts. Here they want horizontal vertical asymptotes down here at the bottom here. First, they want domain and range. So then they want all of them here. So I think what we're going to intercepts, asymptotes, sketch a graph, and domain and range. We want the whole worksheet. So I think I remember working 43 last time. I think I'll work 45. Page 345. R of x, we have 3x squared, add 13, and then x squared minus 4x and plus 4. All right, they want intercept, so x-intercept, y-intercept. They want asymptote, so horizontal asymptote. Some of these are really easy, some of these a little more work. Vertical asymptote. And then they want domain and range. Oh, and they also want a graph in here. So why don't I just go from easiest to hardest? And about the easiest is the y-intercept. That means x is 0. So your y, and this is y, would be 3 times 0 squared minus 12 times 0, add 13, and 0 squared minus 4 times 0, and add 4, and you get 13/4. It makes sense. Remember how we said individually, your y-intercept is always the number on the end? So if you take and divide two of them, it's going to be the ratio of the numbers on the ends, because x is 0 kills every x term in front of them. X-intercept, a little more work. You're going to have the top. Y is 0, so if y is 0, you only care about the top equaling 0, which means you got 3x squared minus 12x add 13 equals 0. Now my guess is this factors, but we quit teaching the factoring. Don't hardly have room to show this. Maybe I'll just go on to another sheet then. I'll show both of them. So if you've got 3x squared minus 12x add 13 equals 0, I'll just charge in the quadratic formula. That's basically the way we teach it now, rather than fiddle around trying to factor it. 12, 144, subtract 4 times 3 times 13. All over 2AB6. Let's see if that root is positive. Basically, I got 144. This root is 144 minus 12 times 13. I don't think it's positive. Second quit. So we got 144 minus 12 times 13. That's negative 12. Square root of negative 12 is an I, so this has no x-intercepts. You will get an I. No x-intercepts. You have 12 add and subtract square root of negative 12 divided by 6. This is I root 12. Okay, handled that pretty easy. The vertical asymptote is pretty easy. This is from the bottom, equals 0. That's where it's blowing up. So that means x squared minus 4x add 4 will equal 0. I hope you recognize the factoring. I could use a quadratic formula, but I hope you recognize the factoring. X minus 2 and x minus 2. And so x equals 2 is the vertical asymptote. And that's very similar to the domain. That means x equals 2 is illegal. So on the domain, 2 Your domain is negative infinity to 2 to infinity. Very close relation between vertical asymptote and domain. Vertical asymptote is the line vertically, vertical line approaches, and then the number of that is the number you can't use in your domain. So that gets excluded from the domain. All right, we have now saved the hardest ones for last. Remember, there was 3 cases of horizontal asymptote. This is a case of top power equals your bottom power. Top power, bottom power. See, they're both x squared. That means it's your ratio of lead coefficients, which means it's 3 over 1, or y equals 3. Okay, we'll use the calculator to get the graph. I'll sketch hopefully a tiny graph of it, and we use that to get the range. 3, y equals 3 vertically on the range is going to get excluded, but there may be something else. It's really dangerous to do the range without a graph. All right, it's a bit of a pit to punch in. Make sure you put the top and bottom in parentheses. 3x squared minus 12x and add 13. There's the top. You're going to divide. Parentheses. X squared minus 4x and plus 4. Close. I guess we'll keep the same window unless I need to see something more, and graph. Okay, looks a little strange, but if you look for these pieces, it can kind of help. Let's see. Let's see the y. That should be bending over and down. Let's just make sure that's happening. Window y. I don't know how high on the y max I got to go to. 50. It wasn't quite good enough. 100. Isn't good enough. Well, I can try to figure out, I don't really have to see it, but basically it's crossing the y-axis at your 13 over 4, which is 3 1/4. It's going up peaking, but then it's dying to 3. It's hard to tell with the scaling so big, but that's dying to 3, crossing the y-axis there. It's going to be very hard to see all these pictures in one graph. Let's see, back to, maybe I should see a small version of it. How about -5, 5, and -10, 10. It acts like it's got an intercept at -2. Did I screw up that? Sure acts like it's touching at -2. But it must be rising up to 3 over here. -2 give you 0 out of that? It doesn't. That's why these things can be misleading. -2 squared is 4, 3 is 12. -2 there would be plus 20. Did I copy this right? X squared minus 12x add 13. No, this is good. Let's see. Yeah. 12 times 13, I think it's 156. That's where you're getting the negative 12. Golly, I think it's dipping here, but it's not touching the x-axis. Okay. Bottom line, yeah, this is a little strange. Bottom line on the range, really you got to find what, you actually do have to find where that peak is because that's your Y max. And down here it's kind of dipping and going up to 3. That's it, you're 3. And you really do have to find that Y max. Oh boy. So 100 didn't work. I'll go to 200. This is really strange. It really, oh, it's blowing up at 2. It's not curling back. My fault. There's a vertical asymptote at 2. No wonder I'm totally confused. My fault. There's a vertical asymptote at 2. So it is going from basically, it's close enough to 0 up to 3, and then from 3 to infinity. Yeah, it's not curling back. My fault. X equals 2 is the vertical asymptote. Yeah, these things are a bit of a project trying to keep everything straight on them. If anybody's watching this to the end of this, 45 minutes in. All right, sorry that was a little rough. We won't be sending a tape of this Zoom meeting to the Teaching Hall of Fame. Otherwise, we will call an end to the meeting and hope somebody comes out at 9 o'clock tonight. We'll see you then.